Hello, friends. Good evening and welcome to Eastern Academy. And we are discussing about electrical fundamentals as part of embedded system programming. And today we are discussing about session 2. And the previous session we discussed about what is voltage, what is current, what is resistance and power and energy. And now we're going to discuss about the relationship between V, I, R, P and energy, power and energy. This is a very nice one. And this will give you lots more insight about electrical. Okay, I'm actually a triple E graduate, so I fairly worked on the electrical very well. So don't worry about that. So I spend my lot of time with electrical. Let's go like this. So we discussed that we have a battery. Am I right? Then we have a current and we have a resistance. That's what ultimate. Everything is only that. This is all about. Nothing more than that. Whether this could be a bulb or fan or heater or motor, we see everything as a resistor. Okay. When we discuss about AC later, we'll discuss what is reactance. Oh, that's also resistor only. There's nothing called reactance and all. We'll discuss about those confusions later. Let us not worry about right now. So the relationship, what they found is, Ohms found out that the relationship V is equal to IR. That he came from other way. He didn't do this. He did like this. R is equal to V by I. That's the first invention. But it's a very confused for you to say. Am I right? We have been always told the I is proportional to R, assuming that R is fixed. But think of initial days when R was not there. That time, what is there was V. Okay. The R is a variable. So they found out that when I change the R, the I is changing. Okay. That's why they always say that R is equal to V by I. That's why they found out if I apply 1 volt, if there's a 1 ampere, then it become 1 ohm. From that only, they came to this formula V is equal to IR. But then they came to one more formula. P is proportional to I square. Please understand. Everybody asked me that I die if I touch the voltage. I die because of the current or because of the voltage. We die because of current, not because voltage does not give you any energy. Please understand. Only the current is giving you energy. Let me be very, very clarity on this. Voltage does not give you energy. Which is giving energy? Only the current. And that is also they found like this. P current power is proportional to I square. So then they found it P is equal to I square. The constant is R, I square R. We know that X proportional to Y means X is equal to CY. We add a C to that, a constant. Whenever you want to convert the proportional to the equal, then we add a constant. That's here, R is a constant which they have added. Understood? This is the way they came. So there are two, but once again they get confused. Hey, how do you say I square R, man? So what they did was P is equal to I square R equal to I into R is equal to I into R into I. All the same now. So I into R is replaced by V into I. That's why it came. And this is only for you to, but the problem is this did do a big confusion. I'll tell you later how come this is confusing you a lot. These two are totally different. Understanding P is equal to I square R and P is equal to VI. If you do this, you will solve the problems very nicely. If you do this, you will always solve the problem wrongly. I'll show you a few examples on next session. Then you will know that. So understand there are only two formulas you have to remember the life. I will not use anything else. In my embedded system programming, in my 35 years of experience, 35 years, I use only two formulas. V is equal to IR, P is equal to VA. Only one more. I'll discuss about that later. Only that. Only three multiplication I remember. Now let us assume this way current. I should never draw like that. This is I. This is R. Now it's a trick. Also, see, V is equal to IR and P is equal to I square R. I can write the I square R into V into I. That's for your simplicity, but that confuses you a lot. That better understand this. Also, this can be, I can write, I can be V square by R square into R is equal to V square by R. You can use this also, one of them. Depends on the requirement, you can do that. But please understand, these are all valid as per the Ohm's law. These are all valid for one voltage, one resistance, and one current. Not the confusion. We should not confuse, because tomorrow we're going to discuss about more. That time I'll give clarity about that. So please understand, there's only one resistor. There's only one voltage I apply. There's one current. Now, here is a problem came. Somebody asked that this question. If I short this, what will happen? Please understand, it could be a battery or this could be a wire. Everything is having a rating. Like I have a tank and I have a pipe. Okay. This everything is having a rating. You cannot give more pressure here, then the pipe will break. Am I right? That's why the issue. Now, same thing here. Here they will tell you the rating. You know what is the rating? Number of electrons per second. But that will be big number. That will be 6.052 into 10 power 18 and all. So they say in terms of ampere. In terms of ampere, they will tell you. For example, this wire, they will tell you that my wire for 1 meter wire, you know that the diameter of the wire, big, small, everything. They call this the gauge. Okay, gauge. Based on that, every wire, they have a measurement, worldwide standard. It's all worldwide standard. 1 meter has how much resistance? R is equal to how much? This is all well defined. Please understand, based on the size of the wire, based on the thickness of the wire. If you have a bigger thickness, the resistor is less. If you have a big thickness, the resistor is still less. Understand? So, based on the thickness, and also when they make it thinner wire, it has a more resistance. When you have a thick wire, it has a less resistance. Also, thin wire have a less gap. Thick wire has more gap. That means that more electrons, more ampere. More ampere. Here less ampere. For example, let's take a very simple example. At your house, you connect a AC, which is going to take about 2000 watts, assuming 2000 watts, 2300 watts. And you apply a voltage of 230 volts. We know P is equal to V into I. You apply 230 volts and you apply 2300 watts. Okay. Now, The issue is here. I is equal to 10 ampere because I is equal to P by V. Understand? So 10 ampere. But if you connect to a very thin wire, which can withstand only up to 5 ampere, you have a wiring at your house. The electrician did the wiring of 5 ampere, thick, thin wire. And your AC is drawing 10 ampere. Now this will burn. This will burn. Understand now why the burning is taking place? The wire can withstand only 5 ampere. You are trying to push more electron through the less gap. There's a more friction, more heat. It's burning. It is burning. Understand that. So you have to be very, very careful. What gauge? They call it as a SWG. Okay, standard width gauge, everything. That's why people are using. So you have to be very clear. Same way, if somebody has asked, if I connect the wire just like this, if we have about 10 meters of wire, that gives you, for example, 0.1 ohm, and you apply 1 volt, for example, 1 volt by 0.1, the current is going to be 10 ampere. How much? 10 ampere. If your wire is going to withstand 5 ampere, it will burn. Please understand, it's burning because of current, not because of the voltage. For example, you have a wire which is very thin, that is giving you the resistor of very thick wire, that is giving you a resistor of 10 ohms. How much? 10 ohm. You apply 10 volt here. You apply 10 volt, the wire resistor is 10 ohm, then the current is 1 ampere, nothing will happen. So you apply here 10 volt, but this is not happening, burning. You understand this now? That is, so every component, a wire, the battery, this is very tricky. A battery, today they both are same. See, instead of giving a 10 volts battery, okay, I can give, let us assume I give you 1 ampere for 10 hours. Okay, then the thing is that I have how much? 1 ampere per minute, per second, then 10 watts per second. Then you can, the battery is having a charge energy for 10 hours. That means that 3,600 seconds. You know that this I'm converting the hour to second. 1 hour is equal to 3,600, and in between 0 is this many seconds into 10 watts. I multiply one more 0. So that many watt seconds. Or if you think it's boring, you can if you wanted to multiply it only by 10 hours, then you can say this is equal to 100 watt hour. Energy can be mentioned in 100 watt hour. Okay. But now you think that this guy is giving how much? 1 ampere for how many hours? 10 hours. I can say this is 10 ampere hours. I can call this as a 10 ampere hour also. Understand one thing. You are drawing 10 ampere for, you are drawing 1 ampere for 10 hours. Then I can call this, both are same. I can call this 100 watt hour or 10 ampere hour. Both are same. Please understand. Don't get confused. Do you understand the difference? Ampere hour, sorry. Ampere hour. So don't get confused these two. This is giving a 10 volt battery. I can supply 10 ampere hour, or I can say 100 watt hour. Both are same. That's why the batteries. Now, the trick here is, this guy will tell you that, who the manufacturer will tell you that I have about now, let us say 1000 ampere hour. That means that if you draw 1 ampere, from me, I can able to give about 1000 hours. Normally, you said your mobile phone batteries of 3000 milliampere hour. Am I right? That means that 3 ampere hour. If we say 3 ampere hour, if you draw, why we call milliampere is I draw that. Let's say I am drawing about 100 milliampere. Then is 3000 by 100 is 30 hours. I can use 30 hours, this battery energy. This is a rated thing. But they will tell you one thing. But if you draw 1000 ampere, then you can do it only for 3 hours. That's why if you watch video and everything, you draw so much more current, then it comes for only 3 hours. But if you don't do anything, you do only a phone call and keep the phone down, then you draw less current, it will come for less hours. That's the thing. You have so much of money. How do you spend it? You spend every day 1000 rupees or 1 lakh rupees. That's the thing. Now, the trick here is that every battery manufacturer will tell you that you can draw maximum 1 ampere per second. That's it. Maximum 1 ampere. If they say that the rating, understand, the rating is 1 ampere. If you draw more than 1 ampere, this battery will burn. You are not supposed to draw more current than the guy gives. That is the reason we are using resistor. What resistor is doing is, it is actually doing the current limiting purpose. Understand? It's actually, if you don't have the resistor, then the circuit will burn. With the voltage, with the resistance, the current will be more than the rated current. Rated current is given by the material manufacturer, how much the wire will do, how much the bulb will do. For example, every bulb is a resistor. Please understand. Not only bulb, motor, everything is a resistor. They may give you watts. They say that 230 watts. If you buy a 230 watts bulb, what is a resistor? R is equal to how much? Can you tell me? If I buy a 230 watts bulb, what is the resistance? Can you tell me? Can I buy a 230 watts bulb? What is the resistance? Yeah, it's 230 ohm. How did you find out? That's very important. How did you find? How did you find this 230 ohm? I have told you, sir, 230 watts.
Sir, Vishnu, you only said, na, sir, bulb and resistor both are equal. So that's why I directly said 230 ohm.
Oh, no. I didn't say that. I never said that. Bulb is a resistant. That bulb is a resistor. Yes, that's all I said. How do you compare watts and resistor? I say bulb is then what is the thing? If you have a 60 watts bulb, what is resistor? It is not 60 ohm. I say all the devices are resistor. I told all the devices are resistor. Understand? I didn't say that watt is equal. I didn't say W is equal to R. I say that all the devices are resistors. But they are telling you watts because common people don't understand ohm. They understand only watts. They don't worry about this. Is a middleman. They don't worry about the watts. They don't worry about R. They worry about watts. Initial days, they were worrying about only HP, horsepower. Later only they started using watts. Now tell me, if I say that 230 watts bulb, what is the resistor of the 230 watts bulb? Anybody? If you could tell me, you are great. If you could tell me that the 230 watts bulb resistor is so much, then you are great. I'll give you some time. I'll wait. Let's see. Let somebody gives you an answer. What is the resistor of a 230 watts bulb? It's a very simple question. Am I right? We all studied everything in the college everywhere. It's a very simple question. I'm asking you, what is a resistor of a 230 watts bulb? Anybody?
Sir, 529.
529
ohm.
529 ohm. How did you find? How did you find 529 ohm?
Power equal to V square by R, no, sir.
Power is equal to V square by R. Yeah.
So V square 230 square, sir. 230 whole square divided by 100.
No, wait. I didn't say that. I have not connected power. I have not connected anything. I have not connected. Somebody asked that what is the input voltage? I don't give a. I am just asking that if you go and buy a 230 watts bulb in the shop, what is the resistor of the bulb? There's a problem. This is the big problem we are all facing. We do not have a proper concept about this. You cannot say, because if I say that if I apply here 230 volts, then tell me what is the resistor. The input voltage, somebody asked about 230, what is the input voltage? I said I input is 230 volts. Then tell me what is the resistance. This may look like a confusion, but please understand, very small concept itself, we have not been taught in the college very clearly. One of the very simplest concept which you should know that. That is the reason we have a lot of confusions on this. What is the resistor now? I say that somebody asked, what is the input voltage? My input voltage is 230 volts. Then tell me what is the resistor of the bulb. No. That's a problem.
Sir, V square by R, na sir. P equal to V square by R. So based on 230 volts, we'll get 230 ohm.
Yeah, that's what you think. But to be frank, if I give you 230 watts bulb, you cannot find the resistor, because if I buy a 230 watts bulb in India, if I buy a 230 watts bulb in US, both are what? Both are 230 watts. Understand one thing. I buy a bulb in India, I buy a bulb in US. Understand? It's a trick here. This K resistor R and this K resistor not same. Then how do you say this 230 ohm? So this itself is a wrong notation. Always they give you two numbers. They always forget about all these things. Any device you take, they have to give you two information. One is 230 watts at 230 volts. 230 watts at 460 volts. 230 watts at 115 volts, assuming. Now, understand one thing. I have three bulbs. It's a bulb 1, bulb 2, bulb 3. This bulb gives you 230 volts if I apply 230 volts. This bulb gives 230 watts when I apply 460 volts. This bulb gives you 230 watts if I apply 115 volts. Now let us draw a circuit. V at the bulb. Let us take the first one. Let us take the first condition. See that. Let us take the first condition. Once you take the first condition, what is happening? This is how much? 230 watts. This is 230 volts. So I is equal to how much? I is equal to P by V. 230 watts divided by 231 ampere. I is equal to 1 ampere. Since I is 1 ampere, R is equal to V by I. V is how much? 230 watts by 1 ampere is equal to 230 ohm. So the first one, which is buy a bulb in India that has resistor of 230 ohm. Now I go to the second condition. I have a bulb of 230 watts, same 230 watts, but if I apply 460 volts, then only that will give 230 watts. Otherwise, it does not. So the current is 2 amperes. Now, V is equal to, R is equal to V by I. What is V? 230 volts. What is R? 2 amperes. Okay. So how much is giving? What's giving now? 115 ohm. So here it is. The second one is 115 ohm. Understand? The third one, same 230 watts at 115 volts. So you apply here 115 volts and 230 watts. So that means that the current is going to be 0.5 ampere. So R is equal to V by I is equal to 230 watts divided by 0.5 equal to 460 ohm. So this is 460 ohm. So understand here, if I don't tell this to you, you cannot find it. I have to tell you that wattage at what voltage. That's the reason when you buy a bulb in US and bring it in India, if you apply higher voltage, that guy will burn because that guy can withstand only that much current. This is called rating. Whereas I'll tell you now, it's very clear. Why I mentioned this was, that means that this bulb can withstand only, this bulb can withstand only up to 1 ampere. This is called rating. If you give more than 1 ampere, this bulb will burn. That means that it gives you 230 watts at 230 volts. If you try to apply more voltage for this bulb, if you apply 300 volts, the bulb will burn because it's getting more current. Now, same bulb here, 230 watts at 460 volts, this guy can withstand up to 2 amperes. That's the way they designed, the manufacturer. So you apply 460 volts, this guy gives 2 ampere, you get about 230 watts. That's why the resistor is 150 ohm. Now, if I have this bulb, 230 watts at 115 volts, then think of it. This guy is how much? 460 ohm. This guy can be stored in 5 ampere. If you connect this one to the different voltage, okay, then that guy will burn.
Sir, for 115 volts, we'll get 2 amperes. No, sir?
For
115 volts.
Okay, how do you get 115 volt 2 amperes? Oh, sorry. Oh, I did a mistake. What mistake I've done here? Sorry, I think I've done a small calculation mistake here. Please, I think I've done a small calculation mistake here. Let me do one by one. I think I've done a mistake. Sorry, I was thinking that what something
For
is going
460, for 460 we'll get 0.5, sir.
460 volt if I apply. Yeah, I did a mistake here. Sorry. If I apply 230 volts, I must divide by here. It's become 0.5 ampere. if you apply here 115 volts, if you give 230 watt, then it become 2 amperes. You are right. Sorry, that's what I was thinking something wrong here. Okay. So this is how much? 46.5 ampere. So P is equal to V by R. So you get V by I, sorry, R is equal to V by I. So 230 volts, sorry, 460 volts divided by 0.5. So the resistor is very high. How much? 920 ohm. In this case, you are applying how much? 115 volts. So 2 ampere. So you subtract 115 volts divided by 2 is equal to 6.5 ohm. That's sorry. I've done I did some division mistake. Sorry. Now this is clear or not? That is, if I confused you, sorry for the 2-3 minutes. You just block it. That's not correct. Now you know that what is the thing here. So I have 3 conditions I told. So if I say only 230 watts, there's no meaning. I should say 230 watts at what voltage? Understand? That's why this guy is having 56.25 ohm. In India, you give a 230 volt supply to the 56.5 ohm. The current is going to be huge, 4 amperes. And this guy can withstand only 2 ampere. So this guy blow up. The bulb is gone. Understand now? That's the way the whole technology works. This is called rating. So every device, today, that is what the trick here. This is very important for us. How it is they will say that we have a LED. That LED will withstand. They tell you that this is a 1 watt LED. Understand? 1 watt LED. Then you have to find out that, and they will tell you that the voltage is going to be 4 volts. They will tell you the voltage is 4 volts. And this is a 1 watt LED. Then you should find out the current. You should pass only that current. If you pass more current, the LED will burn. Understand? Every device is having a rating, but they will not tell you the rating directly. Nobody will tell you. For example, you heard about 1 watt resistor, quarter watt resistor. What do you mean by 1 watt resistor? Let us say I say that I'm having a 100 ohm 1 watt resistor. What it means? Can you tell me? What it means? I have a 100 ohm 1 watt resistor. What it means? Can you tell me? I'm giving you this information. 100 ohm 1 watt resistor. What it means? What is the meaning of this? If I say 100 ohm 1 watts, what is the meaning of that? Anybody, please. That's very important.
Sir, I think it can mean that the resistivity can stop, the resistor can stop 1 watt provided the voltage is 10 volts.
Much more clarity. We need to have a more clarity answer. The answer is fairly correct, but more clarity. So it's like this. Assuming that I have a circuit, I put the resistor, which is 100 ohm. you know that I square R is equal to P. I square is P. Now, let's take 10 ohm easy. That's easy to remember. 10 ohm. I square R is equal to P. Now, I square is equal to P by R. P is 1 watt. 100 ohm may be easy. 100 ohm may be easy. 1 watt. 1 watt divided by R is how much? 100. So 1 by 100 is how much? 0.01. Or let's take 1 by 100 itself. Let's take 1 by 100 itself. So R is I square is equal to 1 by 100. I square. So I is equal to, therefore, I is equal to 1 by 10. Understand? 1 by 10 is equal to 1 by 10 ampere, which is equal to 100 milliampere. That means that if you pass here more than 100 milliampere, this resistor will burn out. They tell you the rate. Instead of telling you that this resistor is 100 milliampere, they confuse you by saying that 100 ohm 1 watt. That's a thing. I don't know how many of the engineering students know that. Electrical or electronic students. We never understand that ratings. This is all very, very important today. If you don't know the rating, your EV vehicle will burn. You connected so many batteries, man. The EV, you have connected so many cells. So many cells. One guy is going to charge faster. One guy is going to charge less. You connect all of them. What will happen? There'll be a current. This device will burn. Am I right? You cannot make all the cells identical. So some cells may be charging faster, some may be charging slower. You have to take care of everything. That is what the embedded system engineer's job today on EV vehicles. That is called actually that big field. Go on search in it. BMS, Battery Management System. This guy is too good on that. Who? Tesla. That's why they won the thing. They won the big order. They became so big because they are good at BMS. If you master BMS, every vehicle company will take you. Simple. But the problem is, don't confuse. If you have any confusion, ask me. If you have any confusion, ask me on this. Take a test. I'll give you all the electrical tests to you. Okay. On the app. Download the app and I'll give you all the electrical tests. Take them.
Sir.
Make sure that you understand this thoroughly. Yeah, ask me.
Sir, only based on the current we have to calculate the rating, sir.
Yeah, not based on current. Current is rating.
Okay.
The rating of the device is current. This is all chumma. All this, to confuse you, I give you wattage. Let us assume that I have a motor. My motor can withstand only 5 HP. My motor is 5 HP. That doesn't mean that 5 into 746 is the watts. Divided by 230 volts gives you the current. That is what the maximum current. That is what the rating. Everything has to be converted to current. Everything has to be converted to current. If I tell you something, let us say that I have a bulb which is 230 watts at 230 volts. I buy it in India. I go and give it in US. There it is 115 volts. Understand now. I buy a bulb in India which is 230 watts at 230 volts. I go and connect it in US. That is giving supply is 115 volts. Then what is the actual power this guy will give? Tell me now. See, that is what I am trying to tell you. Please understand. We are not good at these two things. V is equal to IR and P is equal to VI. We do not understand this very clearly. That is our problem. You're supposed to give an answer for this question in about 5 to 10 seconds. That perfection, you should have that. We try to proceed to subtraction without knowing addition. We try to proceed to multiplication without knowing subtraction. We try to proceed to division without knowing multiplication. This is a wrong methodology. This is the reason you are asking me, give me a job, get me a job. If you know these things very clearly, you will never ask me. You will have a confident, hey, if you don't give a job, your company lose a great man. I'm not worried about that. That's the way you should be. You should never ask for a job. You should never ask. Please understand.
Sir, for this actual power is 115 volts, right?
That is what you are assuming. You are assuming. Indian bulb will not work in US. Why? Why? Why it will not work?
Sir, am I audible? Sir, am I audible?
Yeah, you're audible.
If it is working at 230 watt at 230 volts, then it is 1 ampere rating. But if 115 volt is provided, then the ampere will be 2 ampere. So, but its rating is 1 ampere. So
no, you're wrong. Out, I guess. Sorry, you're not understood. You're wrong. Your answer is wrong, perfectly wrong. That's why I'm telling you that if you answer this question, what is the actual power I get it in US? If I apply 115 volts, you understand P is equal to VI, which you have not understood. You have never understood these two formulas correctly. Please understand. You never understood what is called rating. These are the biggest problem. This you have to get it by heart very clearly. This is very simple. We do a lot of things. No, it's wrong. It is not 115 watts. Please, it's wrong. When I say it's wrong, means it's wrong. See that? See, please take this as a very positive. Take this as a very positive moment. Don't take a negative. If you finding it at the so early stage of your career, you have to understand these things very thoroughly. This will impact you when you are doing actual embedded system. The company will price you. You go to the meeting, you say that this is what this. When all the other people don't understand this, you are the one guy understand that. That's it, man. You are the great guy in the company. You don't understand. I'm not asking big. I'm not going to Thevenin's theorem. I'm not going to Kirchhoff law. I'm asking only two formulas. V is equal to IR and P is equal to VI. Do you understand my problem? And if you ask me to solve the problem, I can solve it now. But when I solve it, you will never understand. I want you to find the method of solving. I don't want to give a fish. I want you to fish. I want to teach you how to fish. That will be a time consuming. I don't mind. I don't mind. See that? The last embedded system programming class, now it is shifting by 1 week. Please understand. 1 week is because I decided to, I don't mind to shipping it to 1 week extra. I want you to understand. That's why I went very slowly. I'm not worried about spending 1 or 2 weeks extra for you to make you to understand. But at the same time, don't ask me how do I solve it. If I give you the solution, you're gone. I've told you all the techniques here. But I'm also telling you that you can solve the problem within 5 to 10 seconds. The moment I write it, you should give an answer. You could not do that. That's a problem. What is the problem? Where exactly you did the mistake? Why you are not trying to analyze? Why you are not? The problem is you did not find the resistor. If you find the resistor R, and we have a V, you give a R. Understand? You can find out I. Then you can find out the power. Anyway, V is equal to V into I, or V square by R, or I square R. Anyway, you will find out. Then what is the problem? Why you are not able to give an answer? Think. These are questions to be asked by you. I've told you the answer can be given between 5 to 10 seconds. That itself is more actually. I expect the answer in 2 seconds. Do you understand now? Do you understand where exactly the problem is? The problem is somebody is giving you the solution so easily in net and everywhere. So you are not trying to solve the problem. I am not asking you to solve a big problem. I am asking you to small problems. You should have the ability to solve small problems in a faster time. Please understand the difference. You solve very big problem in the college. Fourier transform to Laplace to differential equation, integral equation, everything, partial differential equation, so many things. But I'm giving you a small multiplication, man. I'm giving you a small multiplication. Okay. You are not able to solve it. Why? I want the answer. I will not give an answer for this. This is what simple. This is very simple as that. If you ask anything now, if you ask anything now, you should be able to give an answer. I buy a bulb. Which is 115 watts at 230 volts. I supply here how much? 230, 115 volts. What is the actual power I get? Should have an answer. 5 seconds. I want the answer in 5 seconds. Learn it. Learn the method. I'll give you the later. I'll give you the problems in the app. By time, I'll put a time constraint. 5 seconds, 10 seconds, like that. Then try to make it faster. Right now, you all can take the test. Actually, you have a test ready. You can take the test. Try to solve them. Not now. Wait. One more session. I'll finish the next session. I'll complete the series parallel circuit also. Then you take this. You understand your problem. Where is your problem now? The problem is you could not find the resistor in 1 second. When I say 150 watts at 230 volts, you should find R is equal to how much? That's it. The moment you find the R, you will find the thing very, very quick. I will not solve it. Sorry. I'm not here to solve you. I've given enough of clues. Nobody can give you such amount of clues. You have this is what our problem. You know that a lot of people are asking me that why I'm not passing the interview, everything. When you don't have this level of confidence on the very small circuit, when you go bigger and bigger, how do you build it? You try to manage. Most people are managing the interview and getting into the companies. Don't mistake me. I don't want. I want to get into the company and grow so nicely. The same method here. I discussed same thing in the last 2 weeks about digital 3 gates, AND or NOT gate, combinational sequential tri-state logic. Then we discussed about RAM. That's it. How we built it. The same thing here. Oh God, how much? 6. First of all, rule number 1. This gate gives you 115 watts at 230 volts itself. I am giving a less voltage now. I will never get more voltage. That's a very common sense. At 230 volts itself, this gate gives you 115 watts. But I am applying only 115 volts. Okay, this guy can never give you more than that. It's not possible. Solve it. I don't. This is the way. Never sleep. Solve it and send me the answers, both the questions, through message, WhatsApp. Okay. Then we practice lots of sums on this. Try to understand. Don't sleep. Go to the room after the class. Make sure that you understand the two. I say that only 2 formulas. V is equal to IR. and P is equal to VI. That's all. And every device is having a rating. If you try to give more current than this rated current, that device will spoil. If I say that I have a 330 ohm resistor, quarter watt, what it means? What it means? If I say 330 ohm, quarter watt, what is the maximum current can flow through that? What is the rating of that? Find out. Practice this multiplications and divisions very fast. Use the calculator. Nobody says that you have to do mentally. Use the calculator. That's a good. Today nobody says that don't use calculator. Use calculator. Okay, so there is some more thing. Please understand some more thing which I have not mentioned here. But we always say that I told you that power is equal to watt, energy is equal to watt hour, or watt minute, or watt second. Depends on how many somebody is using, or kilowatt hour. We have more wattages. For example, I have a circuit. I apply 230 volts. I connect a bulb of 100 watts. How many 100 watts? And I on the switch for, let's say, 10 hours. 10 hours, I on the switch. Then the energy, this guy power is 100 watts. Energy is 100 watts into 10 hours is equal to 1000 watt hour is equal to 1 kilowatt hour. This is called 1 unit. Nowadays we call in our houses, government charges 6 rupees. No, not 57.5 watts. Sorry, that's not the answer. Yeah, God, Mohammed, you have done a beautiful work. It is 28.75 is the perfect answer. Great. You are the newcomer, first year of engineering, started doing a very good work. That's it. This is the way you practice. The thing is that you found the right answer. That is called functionality. But this took some time. Now you have to make a performance. Increase the time. Make it faster. Do the same sums, multiple sums, faster. And third one is reliability. If I ask you 10 sums, 10 problems, all the 10 should be correct. You should never make even one mistake. So initially you should know how to solve the problem. Now you found it. Now you have got it. 28.75 is the right answer. He got the right answer. Okay. Now the next one is make it faster, and then do it this one. What do you call it? Reliability. This is the steps you follow in every topic, but don't try to become too many topics. That is what the trick. Industry wants is take small topic and make this 3. Then you win the game. You take every topic. No, even the moment you take one topic, you should be the master. Perfect. I was very happy about that. Not many people have given this answer correctly. You have taken a right step. You have fairly understood the problem. Otherwise, you will not get this answer. We'll give you lots of sums in the application app. Then you will be able to solve the problem in the app. I think I'm not given the app to use. I'll do the thing. Okay, then let's stop this. So don't get about too much about that. But this is important. These things are very, very important. And understand the relation of all the 3. V is equal to IR, P is equal to VI. There were 5 components, but all of them are interrelated. Please make it very clear. That I'll tell you that when I'm discussing about electronics, this is going to be related to transistors. That time you will understand that why it is. Never give more current than the rated current. rated current is given, the device will, your body can withstand only so much current. If you touch the 230 volts, your body, more current is going through your body, you're burning. That's the reason. If you touch the 1.5 volt or 12 volts, you don't burn because you get less current. Please. I hope you understand that. Okay. So any question you can ask me. But it will be very simple, but going to give you a lot more in-depth knowledge of things. Lot more never proceed further by having the doubt on these topics. Don't ever, this topic is very simple. That's why we have done. We thought this all Ohm's law and power law, nothing. We throw away and gone. Okay, but that's not true. We don't know how to apply them very correctly.
Sir, excuse me, sir.
Yeah, ask me.
Sir, what is the difference between fuse and resistance? Sir? Both operate same functionality.
Which one?
Fuse wire and resistance. Sir.
Oh, both are same. Both are, fuse is also resistor. Only problem is that has a low melting point. So it will burn. The moment the resistor, before resistor burns, the fuse will burn.
Okay.
That's same. Both perfectly, you are right. Both are same. That guy is having a low melting point. That's the only thing. Both are same. Because of no melting point, that guy will burn first. Because of that guy burns, there's no current. Because of current, all the other devices are saved. Let's say you have a 10 resistors and a transistor, everything is there. And you have one fuse. If the fuse blows, nothing will happen to the device. All the devices are saved. Very simple concept. It's very good. That's it. Actually, you put a right thing word. Fuse is also a resistor only. Okay. It is not something great. Same way, all your heater, every device is a resistor. Please understand. Every device is a resistor. That's it. Nothing more than that. You have only three, V, I, and R. The R, there are so many types. XE, XL, inductor gives you different resistance, and capacitor gives you different resistance and everything. That we will discuss later when we are discussing about AC. First we have to make I have to be very convenient. I have to be convinced that you have understood about this power. I'm thinking a lot mechanism. I'm going to give lots of things such a way that whoever understand these things, I wanted to give them more and more topics. I'm coming out in maybe next month. By April onwards, I'll come out with a new concept. The people who put a lot of energy will get more. Only for them, I'll give those topics will be by only invitation, not by paying money. These beginners topics are money, but the people, those who actually put the effort, will be come to the other topics. Otherwise, it's waste. Just listening to the topics. I want people to effectively, but I told you once again, very clear. From beginning, I'm telling you, in my 35 years of experience, I never used more than addition, subtraction, multiplication, division. Understand? Here also, I will be using only the 4. Addition, subtraction, multiplication, division. I'll never use more other than that. So don't think that I'm going to use some big this thing and all, a mathematical equation. Not required at all. These 4 you can do wonderful work. But you should know how to apply. You should know when to use brake, when to use accelerator. By mistake, if you use the accelerator than a brake, you know that what happened to Chennai yesterday. One guy in Ben's car, instead of applying the brake, he put the accelerator. He killed somebody. That's it. Okay, it's a fate. Understand? Same thing. You should know when to apply what. the problem is most people do the same thing. When I do the voltage and everything, they assume. Never do assumption. This is all engineering. This is not your literature or movie or anything. This is engineering. You should have a proper explanation why I got the answer. Why I got the answer. Every small problems, you learn it the perfect way, not at the confused way. Learn it the perfect way. That's the most important. Okay, then. Have a nice day. We'll meet tomorrow. Okay. Tomorrow is going to be other topic. That is embedded system programming topic. Okay. Our electrical topic will continue on Thursday, Monday, and I give you the 3 days for you to practice. These are all some techniques. I know that. That's why I'm following that. Otherwise, I can make it continuously 2 days and teach you. Why I don't do those first? Why I don't do this first? I learned the way how your brain works. If you give a gap and then you give a discussion, you take it from your brain. That time it comes out. You will be able to think it better.